Hello! Today's lesson is on braking. So we're going to start by thinking back to some prior knowledge, and I'd like you to answer the two starter questions. Those are the ones under the word starter on the screen. Okay, so have a go. First of all, what type of energy does a moving car have? That would be kinetic energy. And what happens to the energy when the car stops? It dissipates, or that's a fancy word for saying it spreads out, into the surroundings. And it does that in the form of thermal energy or heat. Okay, so braking forces. The way brakes work is they apply a force, friction, to a wheel, which slows down the rotation of the wheel. It's actually the friction between the wheels and the road, though, that causes the car to come to a stop. The friction causes kinetic energy to be transferred into heat in the brakes and the wheels and the road. So all of those things are going to get a little bit warmer as a result of it, and the air surrounding it as that heat gets transferred further away. Now, stopping distance is made up of two parts. It's the thinking distance and the braking distance. The thinking distance is the distance travelled from when the driver sees a problem to when they press the brake, and that depends on the reaction time. The braking distance is the distance travelled between the brake being pressed and the car coming to a complete stop. The place where people often go wrong is they say thinking distance is the time it takes for. Thinking distance is the distance travelled, always that. Okay, so what I'd like you to do is I'd like you to think of some factors that affect either the thinking or the braking distance, and then I'll go through some in a minute. So pause the video and have a go at coming up with some of your own. Okay, so factors affecting thinking distance, you might have come up with alcohol or drugs. Tiredness also affects your thinking distance. The tighter you are, the longer it's going to take you to react. Distractions affect thinking distance. Your age affects your reaction time as well, so that affects thinking distance. And the speed you're going at. Whilst your reaction time will stay the same, the faster you're going, you'll travel further in that reaction time. For braking distance, the factors that will affect it, the quality of the brakes and the quality of your tyres as well. So if they have got quite smooth, then you're going to take longer to brake. The type of road surface is also going to have an effect. The mass of your vehicle. The heavier your vehicle is, the more kinetic energy it's going to have, so the greater the frictional force needed for it to come to a stop. Weather conditions. So whether it's icy or wet on the road, those will affect the amount of friction between the wheels and the surface. And again, the speed. The faster you're going, the further you're going to travel. Okay, so we need to look at estimation. Now, these estimations are looking at 26 meters per second. That's the same as 60 miles an hour. So pause and have a go at answering them, and then we'll have a look. So in our first case, we're asked to estimate the stopping distance for a car travelling at 26 meters per second. If we look on our table here, for 60 miles per hour, that would be 73 meters. So 73 meters, if you got a number approximately equal to that, you've done quite well. Again, with estimation, we're not looking for you getting it dead on. The next one was asking for half that, so that would be 30 miles an hour, which is 23 meters. Note that if you half the speed, you're more than halving the stopping distance. And that's because kinetic energy is related to velocity squared. Okay, stopping distance for a lorry travelling at 26 meters per second. That's going to be higher than for a car because it's got a much greater mass. So you probably said something between 80 and 90 meters. And then in icy weather, it's going to be even further, okay, because you've got that reduction in friction. Okay, so you're going to do a little practical today. You're going to do some tests on reaction times. First of all, you need to decide what you're going to test. You've got two options here. You can test whether distractions affect your reaction time or whether caffeine affects your reaction time. First thing you need to do after you've decided which you're testing is to write your prediction. So you need to explain what you think will happen and why. Once you've written your prediction, the next thing to do is to draw a results table that you're going to put your results in. You're going to get 5 repeats for each try and then work out the mean. You'll do that by using this website, which will help you find your reaction time, and it will even work out the mean for you. If you're doing, so you do a test without changing anything, normal reaction time, then if you're doing option 1, you need to repeat it with someone talking to you while you're doing it. If you're doing option 2, you need to drink your caffeinated beverage, tea, coffee, cola, and wait 10 minutes for some of that to get into your bloodstream, and then repeat the test. Step 6 is to draw a graph of your reaction time, probably a bar chart. I don't mind if you do that by hand on a piece of paper, or whether you do it using a spreadsheet package. And then you need to write a brief conclusion saying what you have found. Okay, so what I would like to be submitted to me is your data, results table, prediction and conclusion.